Hi, this is Mrs. Ziegler, and I'm going to go through your free fall notes. So, what does free fall mean? Okay, well, free fall is the movement of an object that is falling towards Earth due to gravity. So, whenever we have a problem for this unit for word problems, whenever you hear the word fall, or I'm sorry, read the word fall or drop, that means it's free fall. Free fall looks like this. So if I take an object and I throw it up in the air, at that moment in which it reaches its highest peak before it starts to fall, at that first second, it's not moving, it stops. So at 0 seconds, it's not moving, so it's 0 meters per second. As soon as it starts to fall towards Earth on that first second, it's moving at a speed of 9.8 meters per second. At the second, it's moving at 19.6 meters per second. By the third second, it's moving at 29.4 seconds. And then again, as it's falling, what's happening is the change of velocity as it falls to Earth is what's called gravitational acceleration, which actually is 9.8 meters per second squared. If we round that, that'd be 10 meters per second squared. Well, next question on your paper says, what happens to the speed of an object as it falls? Well, the speed of an object increases by 9.8 meters per second, which is the acceleration to Earth due to gravity. So when you're thinking of different objects, heavy and light, these objects will fall at the same rate or speed and have the acceleration of 9.8 meters per second squared due to gravity. All right, so on the next side, we are doing the equations. These are the last equations that you will need for this unit. So we have V is equal to GT, D is equal to GT squared divided by 2. So G, which stands for, again, gravitational acceleration, which is 9.8 meters per second squared. So whenever you see G, we're talking about an acceleration, but specifically it's a constant, which means gravitational acceleration, which is always 9.8 meters per second squared. So what that means is anytime we have the problem that says fall or drop, automatically one of our knowns is G is equal to 9.8 meters per second squared. Okay, now V stands for velocity, meaning how fast is something going, whereas D stands for distance. So we're talking about how far it is from, essentially, when we're talking specifically for free fall, we're talking about how far it is from the ground. So, doing the practice problems on your note sheet. First one says an object falls for 6 seconds. How fast is it going? Well, again, the word fall tells me that I've got G is equal to 9.8 meters per second squared. Then seconds tells me I have time. So the question asks, how fast is it going? So therefore, it's how fast, which is speed and velocity. So we're going to use this formula. So I have all the information that I need. I'm going to plug it in. Again, I have right here, you could see I have seconds, and then here I have seconds squared. So this seconds will cancel out one of the 2 seconds. And when I multiply, then I will have the units of meters per second, which is the unit for speed velocity. So once I multiply them, that is my correct answer. Again, numbers are next to each other. Mathematically, we would multiply. All right, next problem. An object falls for 6 seconds. Again, same statement, but now the question says, how far has it fallen? Again, how far? So it has fall in the problem, so therefore I know 9.8 meters per second squared. Then it says time for seconds, okay? But now since it's how far, which means I'm asking for distance. So this is the formula. I have everything I need. I plug everything in. Again, mathematically, you should see here that I'm squaring the time, which means I'm going to square the 6, then I'm square the seconds, so that means seconds squared divided by seconds squared. We'll cancel that out so that the only unit that I have left is the unit that I want, which is meters, which is distance. For this particular problem, the thing that students will forget when doing the calculation is that you have to square the time before you multiply it. Okay, so again, as long as you have everything that's listed here, if your mathematical is incorrect, you will still get full credit. All right, the last problem is going to be the one that's going to be the most difficult for students to solve. So it says, how much time will it take for an object to fall 36 meters? Again, the word fall tells me it's a free fall, so automatically I know 9.8 meters per second squared. Meters tells me, again, that unit tells me I have distance, and then I'm solving for time. Well, remember, in the equations, time is in both of them, but because I've been given the information of distance, I'm going to use this formula, and I'm going to plug it in to the formula based off of what I have. So now, again, if you are intimidated by the math to solve for t, as long as you have all of this information, and then your answer over here is t is equal to the unit of time, which is seconds, you will still get full credit. But I'm now going to go through and show you the math as to how I would solve for t. All right, so again, this is all the information. So remember, I'm solving for t. Right now, I just want to get rid of everything that's over here that's next to this t squared. So again, mathematically, since it's being divided, I'm going to multiply. So think opposite math. So 2 divided by 2 will cancel out. But since I did it on one side, I have to do it to the other. Okay, so canceling out that 2. Now I only have 9.8 meters per second squared. So again, I'm trying to get rid of this. Since it's being multiplied by t squared, I'm going to do opposite math, which is going to divide by 9.8 meters per second squared, and that will cancel this out. But since I did it to one side, I have to do it to the other. So now I just have t squared is equal to this. So now I'm just going to do the math. So again, numbers next to each other are going to multiply. 2 times 36, then divide by 9.8. My meters will cancel each other out, so all I'm really left with is the meter squared. Okay, so now this is t squared is equal to 7.3, which I rounded, to seconds squared. So in order to get t squared, because this is not my answer, I need it to just be seconds. So therefore, I'm going to take the square root of both sides. And therefore, the correct answer would be t is equal to 2.7 seconds, because 2.7 seconds is the square root of 7.3. And seconds is the square root of seconds squared. Again, if you have any questions, please make sure you reach out. But again, remember, the math is not what I need you to make sure that you're able to do, even though you are supposed to. As long as you can identify your knowns and your unknowns, which formula you're going to use, you plug everything in with its units and give me the correct unit for your answer, you will still get full credit. Reach out if you have any problems.